Welcome to sureshbhattclasses. We are solving questions on quantitative aptitude topic numbers. All the topic of quantitative aptitudes are useful for all competitive exams like Bank PO, RRB, SSC CGL, Railways and many government job exams and job interviews. These topics are extremely useful for all entrance exams like GRE, SAT, ACT, CAT, GMAT and many more. Please watch all my videos on quantitative aptitude topics for preparation of all these exams and interviews. In this video, we are solving question on factorial. Our question is, find number of zeros at the end of 51 factorial minus 50 factorial. The given options are option A 12, option B 10, option C 15, option D 14. Before solving this question, I request you to please subscribe to this channel. 51 factorial can be written as 51 multiplied by 50 factorial minus 50 factorial. We take common 50 factorial and this gives us 50 factorial multiplied by 51 minus 1, and this is equal to 50 factorial multiplied by 50. Now 10 is not a prime number, so 10 is equal to 2 multiplied by 5, and we have to find the power of 10 in given question to find the number of zeros at the end of the number. And as 2 is less than 5, so the exponential power of 2 in 50 factorial will be more than power of 5 in 50 factorial. So we will find only the power of 5 in 50 factorial, and that will be the power of 10 in 50 factorial. So we divide successively 50 by 5. 5 divides 50 for 10 times. We again divide 10 by 5 and it divides it for 2 times. And the sum of the consecutive quotients are 10 plus 2 is 12. And this will be the power of 10 in 50 factorial. Now we have 50 factorial multiplied by 50 can be written as 5 to the power 2 multiplied by 2. So the power of 5 in 50 factorial is 12 and power of 5 here is 2, and 12 plus 2 gives us 14. So the number of zeros are 14 in the given question, and from the given options our answer is option D 14. I hope you have understood the method of solving such type of questions and the solution of this question. We go to the next question. Our question is, find number of zeros at the end of 73 factorial plus 74 factorial. The given options are option A 15, option B 16, option C 18, option D 19. Before solving this question, I request you to please subscribe to this channel. 73 factorial plus 74 factorial can be written as 74 multiplied by 73 factorial. We take common 73 factorial. So 73 factorial into 1 plus 74, and this is equal to 73 factorial multiplied by 1 plus 74 is 75, and this is equal to 73 factorial multiplied by 75 can be written as 25 multiplied by 3, and 25 is 5 to the power 2 multiplied by 3. So this is 73 factorial multiplied by 5 to the power 2 multiplied by 3. Now we have to find the number of zeros in the given question, and number of zeros is nothing else but it is the power of 10 in the given number. 10 is not a prime number, So we split this 10 into two prime numbers, which are 2 multiplied by 5, and 2 is smaller than 5. Therefore, the exponential power of 2 in 73 factorial will be more than power of 5 in 73 factorial. So we will find only the power of 5 in 73 factorial. That will be the power of 10 in 73 factorial. So we successively divide 73 by 5. 5 divides 73 for 14 times, as 14 times 5 is 70. The quotient is now 14. We divide 14 again by 5, and 5 times 2 is 10. The new quotient is now 2. The sum of these two quotients is 14 plus 2 is 16. And that will be the power of 5 in 73 factorial. The 73 factorial multiplied by 5 to the power 2 multiplied by 3 is the value of the given question. Now power of 5 in 73 factorial is 16 plus power of 5 in 5 square is 2. 16 plus 2 is 18. So the power of 5 in given question is 18, and that will be the power of 10 in given question, and that will be the number of zeros in 73 factorial plus 74 factorial. And from the given options, our answer is option C, 18. That is, the number of zeros at the end of 73 factorial plus 74 factorial is 18. I hope you have understood the method of solving such type of question and the solution of this question. We go to the next question. Our question is, find the number of zeros at the end of number 3 raised to power 10 minus 3 raised to power 9 minus 3 raised to power 8 in one parenthesis, and into in second parenthesis 7 to the power 10 minus 7 to the power 9 minus 7 to the power 8. The given options are option A 2, option B 3, option C 1, option D nil. Nil or no zeros. Before solving this question, I request you to please subscribe to this channel. We have to find the number of zeros at the end of 3 to the power 10 minus 3 to the power 9 minus 3 to the power 8 multiplied by 7 to the power 10 minus 7 to the power 9 minus 7 to the power 8. This question seems to be very difficult, but it is extremely easy question. On observing the given numbers, 3 and 7 both are odd numbers, and whatever may be the power of 3 or 7, it is going to give the odd number, and odd number multiplied by odd number gives us odd number always. So there will not be any even number, and without any even number you are not going to get any zero at the end, because 10 itself is an even number, and for obtaining or for finding 10 in any number you need 5 multiplied by 2 or 5 multiplied by any even number. So on solving, even if we get 5 in any of the parentheses or any of the bracket, then also we are not going to get any even number or 2. So without having 2, which is to be multiplied to any 5, you are not going to get any 0 at the end, because the product will never be ending with 0. So our answer will be option D 0 or option D nil. There will not be any 0 at the end of solution of this question. This is the shortcut which I have explained you. Now we can solve it also. We can take out 3 to the power 8 from first parenthesis or first bracket, and it will be 3 to the power 2 minus 3 minus 1. And in second bracket, again we can take out 7 to the power 8 and we will get 7 square minus 7 minus 1. So this is going to give us 3 to the power 8 multiplied by 3 to the power 2 is 9. 9 minus 3 is 6. 6 minus 1 is 5. Multiplied by 7 to the power 8. And 7 square is 49. 49 minus 7 is 42. 42 minus 1 is 41. And on observing this number, we cannot have any even number here in all the multiplications or in all constituent numbers. So there will not be any even number which is to be multiplied to 5 to make it 0 at the end. So there will not be any zeros at the end of the given question. And from the given options, our answer is option D, nil or no zeros. I hope you have understood the concept behind it and the method of solving this question. We can straight away say that there will not be any zero or nil zeros in this question, looking to the digits 3 and 7 and their powers in the question. I hope you have understood the method of solving it. We go to the next question. Find number of zeros at the end of number 3 to the power 16 minus 3 to the power 15 minus 3 to the power 14. These all are in one parenthesis, multiplied by in another parenthesis 2 to the power 10 minus 2 to the power 9 minus 2 to the power 8. And given options are option A 1, option B 2, option C 5, option D nil. Before solving this question, I request you to please subscribe to this channel. In the given number 3 to the power 16 minus 3 to the power 15 minus 3 to the power 14, we take common 3 to the power 14 and that will leave 3 to the power 2, which is 9, minus, after taking 14 from 15, there will be 3 to the power 1, so it will be 3, minus 3 to the power 14 we have taken common, so there will be only 1, multiplied by 2 to the power 10 minus 2 to the power 9 minus 2 to the power 8. We take 2 to the power 8 common and we will be getting 2 to the power 2, which is 4, minus 2 to the power 1, which is 2, and 2 to the power 8 we have taken common, so there will be 1 in place of 2 to the power 8. So this is equal to 3 to the power 14. 9 minus 3 is 6 minus 1 is 5, multiplied by 5, multiplied by 2 to the power 8, multiplied by 4 minus 2 is 2 and 2 minus 1 is 1. This can be written as 3 to the power 14 multiplied by 5 multiplied by 2 multiplied by 2 to the power 7, and this gives equal to 3 to the power 14 multiplied by 10 multiplied by 2 to the power 7. So this is only one 10 we are getting in the given question. So there will be only one 0 at the end of the given question. And from the given options, our answer is option A 1. There will be only one 0 at the end of the given number. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find number of zeros at the end of number 1 raised to power 1 multiplied by 2 raised to power 2 multiplied by 3 raised to power 3 multiplied by 4 raised to power 4 multiplied by, this goes up to multiplied by 50 raised to power 50. The given options are option A 400, option B 375, option C 350, option D 300. Before solving this question, I request you to please subscribe to this channel. In the given number, 1 to the power 1 multiplied by 2 to the power 2 multiplied by 3 to the power 3, it goes up to 50 to the power 50. And we have to find the number of zeros at the end of this number. And number of zeros is nothing else but the power of 10 in given number. And that power of 10 can be obtained from the power of 2 multiplied by power of 5 in given number. As there are many even numbers, so the power of 2 will be more than power of 5 in this number. Therefore, we will only find the power of 5 in this number, and that will be the power of 10, and that many number of zeros will be in this number. So we will find the all multiple of 5 in this number. So this is 5 to the power 5 multiplied by 10 to the power 10 multiplied by 15 to the power 15 multiplied by 20 to the power 20 multiplied by 25 to the power 25 multiplied by 30 to the power 30 multiplied by 35 to the power 35 multiplied by 40 to the power 40 multiplied by 45 to the power 45 multiplied by 50 to the power 50. Now we will find only 5s out of these multiple of 5s. So this gives us 5 to the power 5, and 10 is 2 multiplied by 5 raised to power 10. So we will find only 5 out of it. That will be 5 to the power 10. Then 15 is 3 multiplied by 5 to the power 15. So we will have 5 to the power 15. In 15 to the power 15 we have 5 to the power 15. In 20 is 4 multiplied by 5. So only we will take 5 out of it, and it will be 5 to the power 20. And in 25 we have to take care of it. There is 5 multiplied by 5. So 25 can be written as 5 to the power 25 into 5 to the power 25. As 25 is 5 multiplied by 5. So each 5 will have the power 25 into 30 is 6 multiplied by 5. So we will have 5 to the power 30. 30 to the power 30 can be written as 6 multiplied by 5 to the power 30. So we will take only 5 to the power 30 multiplied by 35 to the power 35 is 7 multiplied by 5 to the power 35. So we will take only 5 to the power 35, as we are only counting the power of 5s. Into 40 can be written as 8 multiplied by 5 to the power 40. So this will be 5 to the power 40, and 45 is 9 multiplied by 5 to the power 45. So we will take 5 to the power 45. And 50 is 5 to the power 50 multiplied by 10 to the power 50. And 10 to the power 50 can be written as 5 to the power 50 multiplied by 2 to the power 50. So we will take only 5 out of it. Memorize or keep in mind, 50 to the power 50 has 2 5s. 5 to the power 50 into 5 to the power 50 into 2 to the power 50. But we are not writing 2 to the power 50. Now we will just add all the powers of 5, and that will be equal to, we are just adding the all powers of 5. So that is 5 plus 10 plus 15 plus 20, and we have got 2 times 25 plus 25 plus 25 plus 30 plus 35 plus 40 plus 45 plus we have 2 times 50, 50 plus 50. So this will be the total number of 5s in given question. So we add these. This is 5, 10, 15, 20, 25, again 25, 30, 35, 40, 45, 50 and again 50. So we just take these 125 and 150 out of it. So it will be an AP 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And we add these numbers. So this will be 10 numbers 5, 10, 15, 20, 25 up to 50. So that will be sum of an AP, and this is n by 2, which is 10 by 2 into first number 5 plus last number 50 plus 125 we had taken out of it and 150 we had taken out of it. So this will be 5. 2 divides 10 for 5 times, and this is equal to 5 plus 50 is 55 times 5 is 275 plus 25 plus 50 is 75, and this is equal to 350. So total number of power of 5 is 350, and that will be the power of 10 in given number. So number of zeros are 350, and from the given options our answer is option C, 350. I hope you have understood the method of solving such type of questions. We go to the next question. Find the number of zeros at the end of number 1 multiplied by 3 multiplied by 5 multiplied by 7, and it goes up to multiplied by 99, and this all multiplied by 2 to the power 15. The given options are option A 12, option B 13, option C 10, option D 11. Before solving this question, I request you to please subscribe to this channel. In the given number, it is a series of odd numbers 1, 3, 5, 7, and it goes up to 99, and it is multiplied by 2 to the power 15. So for finding number of zeros, we have to find number of 5s in 1, 3, 5, 7 series, and we have already 2 to the power 15. So whatever may be the power of 5, that multiplied by 2 to the power 15 will provide number of zeros. So we have to find the number of 5s in the given series 1, 3, 5, 7 up to 99. So first will be 5 itself, then next will be 15, then 25, then multiplied by 35, multiplied by 45, multiplied by 55, multiplied by 65, multiplied by 75, multiplied by 85, and multiplied by 95. So these are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. These are 10 5s, plus there is one more 5 in 25 because 25 is 5 to the power 2. So that will be 11, and another will be in 75, which is 25 multiplied by 3. That is, again we will have one more 5 in 75. So we have already calculated 10 plus these 2. There will be total 5 to the power 12. Now we already have 2 to the power 15 multiplied by 5 to the power 12. So this is going to give us 10 to the power 12. So there will be total number of zeros equal to 12. And from the given options, our answer is option A, 12. We are going to have 12 zeros in the given number. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find number of zeros at the end of number 2 to the power 15 factorial multiplied by 3 to the power 17 factorial multiplied by 5 to the power 19 factorial multiplied by 7 to the power 21 factorial. The given options are option A 15 factorial, option B 17 factorial, option C 19 factorial, option D 21 factorial. Before solving this question, I request you to please subscribe to this channel. The number of zeros at the end of any given number is nothing else but 10 to the power in given number. Whatever may be the 10 to the power in given number, that will be the number of zeros at the end of that number. And 10 constitutes 2 multiplied by 5. So we have to find the number of 2's and number of 5's. On the basis of, we can find number of power in 10. In the given number, we have 2 to the power 15 factorial multiplied by 5 to the power 19 factorial. So this is going to give us 2 to the power 15 factorial multiplied by 5 to the power 15 factorial, and this is equal to 10 to the power 15 factorial. We will take out 15 factorial out of 19 factorial to make the equal powers in 2 to the power 15 factorial multiplied by 5 to the power 15 factorial, and that is going to give us 10 to the power 15 factorial, and that will be the number of zeros in given number. So our answer is number of zeros are 15 factorial. And from the given options, our answer is option A 15 factorial. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find number of zeros at the end of number 26 factorial multiplied by 36 factorial multiplied by 52 factorial. The given options are option A 15, option B 17, option C 21, option D 26. Before solving this question, I request you to please subscribe to this channel. For finding number of zeros at the end of the given number, we have to find the power of 10 in given number. But 10 is not a prime number and 10 is equal to 2 multiplied by 5. So we will find power of 5 in given numbers, and that will be the power of 10 in given numbers, as power of 2 will always be more than power of 5 to make it power of 10. So we will only find the power of 5. So we will successively divide 26 by 5, and 5 divides 26 for 5 times. We again divide 5, and 5 divides 5 for 1 time. So this is going to give us 1 plus 5 is 6. So this is going to give us 5 to the power 6. Now we will divide successively 36 by 5, and 7 times 5 is 35. The quotient is 7. We again divide 7 by 5, and 5 times 1 is 5. And this is going to give us 8. 7 plus 1 is 8. So we will be getting 5 to the power 8. Now we successively divide 52 by 5. 5 divides 52 for 10 times. We again divide 10 by 5, and it divides for 2 times. 10 plus 2 is 12, and this is going to give us 5 to the power 12. So we are getting 5 to the power 6 multiplied by 5 to the power 8 multiplied by 5 to the power 12, and this is equal to 6 plus 8 is 14 plus 12 is 26. So this is equal to 5 to the power 26, and this will be the power of 10 as well. We will have 10 to the power 26 in given number, and therefore there will be 26 zeros at the end of given number. And from the given options, our answer is option D 26. I hope you have understood the method of solving such type of questions. Here completes this video. Please like, share and subscribe to this channel, and don't forget to press the bell icon to get the latest notifications. Thanks for watching.